We're going to take a look at intercepts, both the x-intercept and the y-intercept. So first we want to identify what an x-intercept is and what happens when we have an x-intercept, and what a y-intercept is and what happens there. So when we're looking at just like a graph, I'm going to just sketch a quick x and y axis here. We have a line. The x-intercept is where this line crosses the x-axis. So right there. Well, if we're crossing the x-axis, think about what the y value is when we're crossing over that x-axis. As we cross over that x-axis, we're at the y value of 0. This is the y-axis. We're at the y value of 0. So the x-intercept is when y is equal to 0. And the x-intercept could be anywhere. The x-intercept could be x equals -5 or positive 10, negative 100. It doesn't matter. But the y value will always be 0 because it's where we cross over that x-axis, meaning the y value of 0. So that's something to keep in mind. Now, what about y-intercepts? Let me just draw another graph real quick. So if I have a line, and I'm now looking for that y-intercept, well, if we're crossing over this y-axis right here, so here would be my y-intercept, that means my x value is 0. X equal to 0 because I'm crossing over the y-axis, which is equivalent to x being 0. So that's another thing to keep in mind. Because when you want to go graph and you want to just use intercepts, you could just take y is equal to 0, plug it into the equation, get back an x value, and that will tell you your x-intercept. Then the y-intercept, take the x value of 0, plug it in, and you get back y value, and then you'll have your y-intercept. So first let's identify x and y-intercepts. So this graph here, we have this blue line going across here. The x-intercept, let's identify the x-intercept. The x-intercept is where it crosses the x-axis. So it crosses right there. So that would be the x value of -1, 2, 3. -3, and then the y value of 0. Notice the y value being 0. The x-intercept is when y is equal to 0. The y-intercept, where we cross the x-axis, or I'm sorry, I almost just said x-axis. The y-intercept is where we cross the y-intercept when x is equal to 0. So right here, so my y-intercept is going to be 0, and then it looks like it lines up with 6, yeah. So 0, 6. And those are the only 2 points where we cross the x and y axis. So number 2, x-intercepts. X-intercepts where we cross the x-axis. This horizontal axis is the x-axis. So we cross right here and right here. So what are those ordered pairs? Well, the x-intercept is 0 because we're crossing the x-axis at the x value of 0 and the y value of 0 because we're crossing through the origin for the x-intercept there. And we have another x-intercept at 2, 0. It crosses right there, 2, 0. Which makes the y-intercept a little bit interesting because we are crossing at the origin. The y-intercept is also 0, 0 because it's crossing through right there. It's crossing through both the x and the y-axis in that single point. So that's an interesting example there of x-intercept and y-intercept. And number 3, the x-intercept and y-intercept. Let's identify the x-intercept. The x-intercept crosses right through here. So that looks like we are at 1, 0. X value of 1 and the y value of 0. 1, 0. Now the y-intercepts, this is just a vertical line at the x value of 1. I don't have any y-intercepts, so I'm just going to say none or no y-intercepts. We don't cross through the y-axis at all, so that's just none. Next, we want to graph these equations by plotting only the intercepts. That's all we want to know, just the intercepts, if possible, if we can actually plot the intercepts, but that's all we want to know right now. So for the x-intercept, that is when the y value is 0, and then for the y-intercept, that is when the x value is 0. So all we have to do is take y is equal to 0, plug it in, and we'll get back the x-intercept. Then we take x equal to 0, plug it in, get back the y-intercept. So x-intercept, y is equal to 0, so it's going to be 2x minus 0 equals 4. 2x equals 4, because 2x minus 0 is 2x. Divide by 2, x equals 2. So the x-intercept is 2, 0. 2, 0. I know I'm a little close to my camera, so let me try to move this up here. And then the y-intercept is when x is equal to 0. So that's going to be 2 times 0 minus y equal to 4. 2 times 0 is 0 minus y equal to 4. 0 minus y is just negative y equal to 4. Divide by negative 1, y equals negative 4. So the y-intercept is going to be 0, negative 4. So 0, negative 4. See how we have 2 points? 2 points is enough to go off of to create a graph. So I'm just going to connect these 2 points. And there's our line. So we just only use the intercepts, and we're able to create this line, no problem. Let's take a look at some additional examples. So this one, we want to use the intercepts. So the x-intercept is when y is equal to 0, because we're crossing through this x-axis. That was when y is equal to 0. And then we want to get the y-intercept is when x is equal to 0, because that is when the x value is 0. We're crossing through the y-axis. That's the equivalent of x equal to 0. So let's go ahead and substitute in our value. So x equals, let me not use blue. So x equals negative 3 times 0. X equals negative 3 times 0 is 0. So the x-intercept is 0, 0. Right? Because we got x equal to 0. So 0, 0. So x-intercept is 0, 0. Y-intercept, plug in when x is equal to 0. So that's going to be 0 equals negative 3y. And then we divide by negative 3. So we also get y is equal to 0. So we get the x-intercept and y-intercept of 0, 0. So then now I have another point stacked on top. That's a problem, because now I don't know what's happening. Is it a line going like this? Is it going like this? Like, what does this line actually look like? So in these scenarios where x-intercept and y-intercept are both 0, 0, we need to grab another point. We need to take something just to give ourselves some idea of what's happening here. So does the line go like this, like this? What is happening with this line? Like, where is this going from? We know it's crossing through the origin in some way, but we don't know what it's exactly doing. So we have to figure that out by grabbing some sort of x value or y value. It doesn't really matter. Let's just say x is equal to, let me not use red. I mean, it doesn't matter at all. We're just trying to get an idea. So let's just take y is equal to 1, I guess. So negative 3 times 1. So x equals negative 3. So taking the y value of 1, you could have chosen an x value of 2, x value of 3, y value of 6. It doesn't matter. Just grab some sort of value, plug it in, and that gives us an ordered pair of negative 3, 1. So the x value of negative 3, y value of 1. Now we have 2 points, and you can grab 3 points if you want, but that at least gives us some idea of what this line looks like. So that one's interesting because we have both the x-intercept and the y-intercept crossing through that origin. So we need to grab an additional point that is not the intercept. But we still use the intercepts though. Let's try this one out. So let's do x-intercept. X-intercept is when y is equal to 0. The y-intercept is when x is equal to 0. So let's go ahead and do this. So the x-intercept is going to be 3x equals 2 times 0 minus 6. 3x equals 2 times 0 is 0. 0 minus 6. 0 minus 6 is negative 6. Divide by 3. X equals negative 2. So the point there is going to be negative 2, 0. Y-intercept, x equals 0. So 3 times 0 equals 2y minus 6. 3 times 0 is 0 equals 2y minus 6. We add over the 6. 0 plus 6 is 6 equals 2y. Divide by 2. Y is equal to 3. So we get 0, 3. And there is our graph. Last one. Graph x equals negative 1, y equals 2 by the intercepts. So for the x-intercept here, let's do x equals negative 1 first. Let's just talk about that. So the x-intercept is when we set y is equal to 0. The y-intercept is when we set x equal to 0. And after you do these problems enough, like, you start to just understand what's going to happen with a graph like x equals negative 1 and y equals 2. So if I'm looking at just x equals negative 1 first, I'll do y equals 2 over here. But if I'm looking at x equal to negative 1, my x-intercept is when I have y is equal to 0. So when y is equal to 0, I don't have a I can't plug in y anywhere. It just says x equals negative 1. So all I know then is that I have a point at negative 1. And then that's going to be a vertical line at x equals negative 1. Where if you think about the y-intercept, if you plug in 0, that would be 0 equals negative 1. That's a false statement, meaning like, well, okay, we don't have anywhere where it's crossing the y-axis because we get a false statement here. We get this false statement, meaning it's not going to cross the y-axis. So let's try y equals 2. Let's do the same thing. X-intercept is when y is equal to 0, and the y-intercept is when x is equal to 0. Let's talk about what happens here. So for the x-intercept on y equals 2, when I plug in 0, because x-intercept is when y equals equal to 0, 0 equals 2, not a true statement. So that means I'm not going to cross through that x-axis at all. Because now, when we're looking at the y-intercept, x equals 0, I just get back the statement y is equal to 2. Just like how I did before. When I tried to plug in y is equal to 0, I just got back the statement x equals negative 1. So y is equal to 2 is just going to be a point at the y-axis of 2, because the y-intercept is positive 2. And there is our line. And think about this just like how we did over here. When we were solving for like the y-intercept for this last one, x is equal to 0. So what we did is we got down to a point when y is equal to 3. So that order pair was 0, 3. Same thing here. When I'm trying to get the x-intercept for x equals negative 1, I plug in y is equal to 0. Well, I don't have anywhere to plug it in, and I just get back x equals negative 1. So that's my x-intercept. X equals negative 1. It's going to be a vertical line because it crosses through there an infinite amount of points. It's going this way. Same thing with the y value of 2. Y is equal to 2. Those would be the intercepts.